Welcome viewers to lesson 2 on probability on our virtual platform. We'll be talking about experimental probability and relative frequency. Let's look at some facts. Probability of all exhaustive events add up to 1. For example, if you look at this spinner divided into 3 sections all equally likely, probability of each color is a third, as you can see. Now from this we can now say that if you add all the probabilities of blue, red and yellow, it equals to 1. That's what I mean by exhaustive events. All the possible events, when you work it out, they must all equal to 1. Now from what we just talked about, it means that probability of an event A not happening can also be written as 1 minus probability of the event A happening. Example, probability that it will not land on blue could be worked out by just working a probability that it will land on blue and take our answer away from 1. So 1 minus a third is 2/3, which is exactly what this statement means. Now let's look at example 1. Probability that a biased dice land on 5 is 0.4. Gabriella is going to roll the die 300 times. Work out an estimate for the number of times the die will land on a 5. Okay, what you need to understand is that these kind of questions, you always see this kind of phrase bias, because each outcome is not equally likely. It's called experimental probability because we assume that some experiment has been done. Okay, now what you need to understand is that probability of 5 is given as 0.4. Now, to get the number of times that will land on 5, if you keep on repeating the experiment 300 times, all you need to do is multiply your probability by the number of trials. So estimate from 300 rolls will be the probability times the number of trials. And that gives us 120 times. So you remember, you work out the probability and you times the probability by the number of trials. That's how you work out experimental probability. Example 2. Try to pause the video to read the question yourself so that you understand, so that we don't need to make the video long. Okay, so from here, we are supposed to work out the trees that will not survive out of 150 if probability of tree surviving is 0.7. Now, you know probability of surviving is 0.7. We are looking of not surviving. So you can work out probability of not surviving by doing 1 minus probability of it surviving. So that gives us 0.3. That's what we need to focus on. So now probability of not surviving is 0.3. So we multiply our probability of not surviving by the number of trees that is planted. So that will give us 45 trees will not survive. One way is also work out probability of trees that will survive using 0.7, and the answer, you take it away from 150. It's the same as what we just done here, but we work out probability by taking away from 1, then multiply to get our answer. Now, we have probability in a table form. So here, Raphael spins a spinner. The spinner can land on red, green, or blue, or yellow. Below is a table showing the probabilities that the spinner will land on red, green, or yellow. So blue is missing. We need to work out probability that it will land on blue. So remember the facts that we showed at first. The probability of all exhaustive events should add up to 1. So if you should add up everything here, it should add up to 1. So let's work out what we have. That gives us 0.8. So, which means that we need a bit to add up to 1. So we need to just take away 0.8 from 1, and therefore we know blue is 0.2. Now, Raphael spun the spin 50 times. Work out how many times it will land on green. Now, we know probability that it will land on green is 0.3. So we need to multiply 0.3 by the number of trials, which is 50 times. And that will give us 15. So it will land, we expect it to land on green 15 times. Example. This example, pause the video, read to understand. Okay, so if you look at this table, 1 and 4 probabilities are given. 2 and 3, we were not given probabilities. But we've been given a clue that the probability that the spinner lands on 3 is twice the probability of 2. 3 is twice probability of 2. So to work out the probability, because we don't know 2, we call it x because we don't know. And 3, we call it 2x because it's 2 lots of x. Now, probability, when you add all answers, you add up to 1. So let's work out what we know. 0.25 plus 0.3 is 0.55. That is not 1 yet, so let's look at the remaining. 1 minus 0.55 is 0.45. This 0.45 is for 2 and 3. They need to be shared. But we have x and 2x. So x and 2x makes 3x. That means 3x represents 0.45. If I know what x is, I will know what 2x is. And to find out what x is, it's a simple equation. Divide both sides by 3. So x will be equal to 0.15. So knowing x is 0.15, double 0.15 to get 3. And that will give us 0.3. And if you add all back, you should get 1. Now we're going to relative frequency. This is where we compare frequencies. Okay, now a die is rolled 40 times, and this is the frequency recording of the outcomes of this score. So we are supposed to work out the estimate of probability that after the next roll, what will be the chance that it will land on 3. This is the outcome from 40 rolls. Now the die is supposed to be rolled again, and we need to predict the probability that it will land on 3. Now all we need to do is that previously from our previous experiment, how many times did we land on 3? Is 4. 4 times. Out of how many times? 40. So to work out the probability that will land on 3, it's just 4 out of 40, which is the same as 1 over 10. We call it relative frequency. We relate the frequency of each outcome with the overall frequency. Now suppose the die is rolled another 240 times. How many 5s will you expect to roll? Okay, let's first understand what happened out of the 40 rolls. Then we scale it up to 240. When it was rolled 40 times, 5 appeared 7 times. So the relative frequency for 5 out of 40 is 7 out of 40. Now we know the relative frequency out of 40. We scale it up to 240 by multiplying the relative frequency by the number of trials. And working that out, that will give us 42. So this is called relative frequency. Now, this is another relative frequency, but we're going to work backwards. So a bag contains hundreds of colored tennis balls. That's a lot of tennis color balls. And Cecilia picked 40 balls at random. And the table shows the outcomes. We have frequency, the number of times, pink, 10 pink balls picked, 18 green balls picked. We were not given the number of yellow and red. We've been given a relative frequency of 0.2. Given this information, we are supposed to complete the table and then use the table to work out if she picked additional 200 balls, how many pink balls should we expect to be picked. So we're going to start working backwards. If you remember, relative frequency is always the frequency over the total number of frequency. So the frequency of red over 40 balls gives us 0.2. So let's call this R. So we are going to make a simple equation. R divided by 40 should equal to 0.2. So relative frequency. Now, can we work out R? We multiply both sides by 40. That means that 8 rare balls were picked. So we know R is now 8. Knowing that R is 8 and knowing that we picked 40, we can now work out what is missing for yellow. Because yellow will be 40 minus 10 minus 18 minus 8. Or we add 10, 18, and 8 and take away from 40. That will give us the number of yellow balls that were picked. So to work out yellow, just 40 minus 10 plus 18 plus 8 into bracket. And that gives us 4. So we know yellow is 4. Now, knowing that yellow is 4, we can now work out the relative frequency. So it's 4 out of 40, which is the same as 0.1. We are leaving our answer as a decimal because the initial question was given in decimal. That's why I'm putting this also in decimal. Now, let's work out the next one, which is pink, is 10 out of 40, 0.25. Then green, 18 out of 40, 0.45. And you can double check, add 0.25, 0.1, 0.45, 0.2. It must equal to 1. Now, having completed this, we are supposed to work out how many pink balls should we expect to be picked out of 200 balls. Picking a pink out of 40 balls was 0.25. We're going to use this one to scale up our answer. So it's 0.25 times the number of trials. So probability, relative frequency of pink, which is the same probability, times it by 200. That's 0.25 times 200. And that will give us 50 pink balls. It's expected to be picked out of 200 balls. And that brings us to the end of our lesson 2. Look forward to lesson 3. We're going to talk about sample space diagram. Lesson 3, sample space diagram. Share with your friends and subscribe. Thank you for watching.